up the quiz. Those are the results. Somebody got 100, one person got a 0. Only 2 people in this class got above 4 out of 6. So this is concerning to me. That we just started a new unit and we're kind of behind in the concepts already. How many people posted their homework to Google presentation? Yes, I've gotten zeros. Thank you. So not a lot, even though we're not understanding it. I didn't see any emails come my way saying, I posted my homework, don't quite get this, Mr. Cam. Can you please comment? We need to be on task. We need to stay focused this unit. This is a very important unit. We can't get too far behind already. This unit will move quickly and it's somewhat long. Alright? Only 4 weeks for March break? The 4 weeks? 3 weeks? Right? It's got to be dedicated, focused 3 weeks. Okay? Any questions? Like, do I not make this clear? Yes, Megan.
Is this the,
This was the first quiz.
like, you know how we did 2 quizzes?
This is the first one. I'm not sure how we did the second one. I don't have time to go look. But you guys all got emailed your results.
As long as you did now.
Yes.
Oh.
That was fast.
Yeah, this is why I'm trying to get us to use technology, doing this on computers so I can get this looked at quickly, address problems. Michael, I seriously recommend that you pay attention. Got it? Don't give me a smirk. You got it. So here we'll look at the segments between E and F. So E is here. Oh, I can't write this. It's not smart word. So E is here, F is here. How do you find the rise and run? First of all, how do we find the rise from E to F? Going from E to F, how do we find the rise? Pooja.
Well, rise is the vertical one, so since you're going down, it would be negative.
Okay, so since we're going down, it's negative. How many going down? 1, 2, 3, 4, 5.
Negative.
So here it eliminates, we only got A or C. Okay, so if we're going down, our rise is negative. In other words, it's a downward slope. If we drew a line from E to F, right? That slope is going down. And the run is going to the right 3, so that's positive. Okay, so the answer is 5, B, sorry, A. Okay, 1, 2 we did all right. Use the slope to find, so that one was did very poorly. So number 3. So we have point E, which is up here. And it says we want, if this was a line going from E to F, right? So if a line going from E to F, so who's got that ruler? I saw it right here, the big one.
Oh, over there.
So we had a line that went through these 2 segments, these 2 points. This is kind of freaking out my smartboard. Okay, so we had a line that went through here, kind of hard to see. So one end is F. Basically, we want to figure out the coordinates of the other points. Okay? So if we know that we have to go down 5 and across to the right 3 to F, what do we have to do to get to another point on the opposite side? So we go down 5, 1, 2, 3, 4, 5, and across 3, 1, 2, 3. We just get back to the same point. Right? So we want to point that somewhere up here, that we have a straight line that goes through here that passes through that point. So we go up 5, 1, 2, 3, 4, 5, and to the left 3, 1, 2, 3, and that puts us at 5, negative 5, comma 7. Okay, any questions on that? You see how we get to the other point? So instead of going down and across right, here we go up and to the left. We do the opposite, going to the other point. That's how we're going to get our 3 points on that straight line. Question?
I got that, but like, could you start from F, or does it have to start from? Because if you went from F, you can just go down, can you?
Well, the question is that E is one endpoint. Oh, E is one endpoint. So basically it's saying E and F is on the same line, but F is on the end of one, so you want it on the other one, okay? I don't think, I mean, given your choices, I mean, even the other one wasn't even on there, right?
that's what I want.
Okay. But I mean, Jenny asked a good question. How could I just even find another point on that line? I could have used F then, which I think log as we did last time. Then we just went 1 down 5, 1, 2, 3, 4, 5, which would put us at negative 8, I guess?
No.
And across 3.
Yeah.
Right. But that wasn't the specific question. The question, do we want on the opposite side of that? So opposite side, opposite point of that. Okay. Any questions on that question? Sounded weird. Okay. Yes.
Be 5, -3 then.
5, negative 3.
Positive 5, -3 for that.
Positive 5,
Because you
negative
go
3 gives us
on the
down
right
here,
side.
right? And if I have a point here, I know it's not going to be on the straight. It's not going to be on that straight line. Okay. You get a question like this? Just take out your ruler and draw a line to those 2 points.
So you always have a ready to bring it.
Yes, have a ruler all the time for this unit, please. We're dealing with lines, linear equations. Having a ruler would be very helpful. The slope of ij so ij, okay, so this was a tricky one. This actually was in the homework question. So here, what's our rise or what's our rise? We're going from I to J.
6. No,
1,
negative 6.
2, 3, 4, 5, 6. So we're going down 6, so it's negative 6. What's our run? Nicholas? 0. So I have negative 6 over 0. That sounds like a familiar math question way back from unit 1. What's anything divided by 0? What's the answer? Jenny?
Yeah. Oh, I thought it was 0. Undefined the other way around is undefined.
Yeah, so if you're dividing by 0, it's undefined. Right? So this one would have been undefined.
What was the number?
I to J, number 5 is undefined. The other one, G to H, a rise was 0. So a rise was on the numerator. 0 divided by anything, except if it's 0. But 0 divided by anything is going to give us 0. So here, when we went from G to H, so we went from G to H, basically it's a horizontal line. It's a flat slope. Right? So we got a flat slope, that means the slope is 0. Okay, a rise is 0. So some of us may have been confused with the 0 and undefined, and that was just a little refresher from unit 1. Yes.
Just to make sure, for a graph, the one that's going horizontally is the y-axis, correct?
The one going horizontal is the x-axis.
Yeah.
The vertical is the y-axis. Okay. Good. However, you need to remember. So we have a ski hill that drops 50 meters for a run of 400 meters. Find the slope of the hill. So it even uses almost the terminology that we use for slope. In this case, it doesn't use rise. What word does it use instead?
Drops.
Drops. So that defines a rise. So it drops 50 meters. So it's dropping down, so it's going to be negative 50. And then our run is what? 400. So negative 50 over 400. There's only one answer, that's a fraction. Right? I'm not a fan of multiple choice questions because you could actually kind of deduce what the answer may be without actually doing the calculation.
That's what I
But it's the best we can do right now. Okay, so the answer is negative 1/8. Right? So the rise is negative 50, the run is 400, reduced as a fraction is negative 1/8. Okay? Any questions with this? Is it a little bit more straightforward now? Okay, good. Okay, so let's pick this up. Okay, so table of values. You guys familiar with table of values? Have you guys done this?
Is it like the input
Science?
machine?
Yeah, sort of like the
We did
first lesson that we did, input output, where x here is our independent variable, y is our output, right, or dependent variable, and we want to do it based on this relationship that's defined, okay? So basically when x is 0, right, we put it into this equation, what value do we get for y?
Oh.
Light bulb went off over here, good. So what do we get for y? We plug in x for 0. Anthony? Negative, sorry?
3.
Yeah, negative 3. 2 times 0 is 0. If we subtract negative 3, we get negative 3. Okay? What happens if we plug in x equals 1 into this equation? What do we get, Andrea? We get negative 1. Because 2 times 1 is 2, subtract 3 is negative 1. What about when x is 2? Dean. 2 times 2 is 4, minus 3 is 1. Good. X is 3. Vince? 3. So 2 times 3 is 6, minus 3 is 3. And finally, last one, Sarah. 2 times 4 is 8, minus 3 is 5. Yes. Okay? So that's what a table of values means, is that we have our input, or an independent variable, x. Whatever values we have for that, we plug it into our equation, and what is our result? What's y? So we plot this. So I'm going to plot this. 0, negative 3. 1, negative 1. 2, 1. And 3, 3. 4, 5. So what are we getting out of this? And again, does it look like it's going to form a line?
The line.
Yeah.
Okay, so you guys had an advantage. You could actually do this in one step. A little bit harder for me.
What's the other problem?
We'll get to this. Okay. So we have a line, right? If we actually plug in every single value of x possible, go into decimals, everything, we will get a line. We plot everything. Now, so what's the slope of this line? 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 Paul?
Should I just give you the answer?
Yes.
in calculation?
How'd you get 2?
I did rise. So I took the entire line segment that we calculated, and I found the rise and the run. So the rise is 8 and the run is 4. And 8.
The whole entire line segment, so you did this whole thing, so you basically used
Those
this
are the
point
points we
here
calculated.
and this point here. So here the rise was
8.
8, and the run was
4. But then I could have also used just one dot between one dot and then.
okay. Yeah, so you can use any points on our line. So you chose to use endpoints. So m is equal to rise over run. So that's equal to here, positive 8 over positive 4, which is equal to 2. Okay? Now what I want you to do on this one, we're going to calculate first difference. Well, actually, before we get there, there's one other thing that I want to talk about. So if you have that column, that third column to label as first difference for now. Now notice I have the x in 0. This gives us a very special point on our line. Okay? This gives us the vertical or y-intercept. What do you think that means? The vertical or y-intercept. Vertical or y-intercept. Leanne?
Where the line meets the y-axis.
Okay.
So the point at which the line meets y.
Yeah, so basically, yeah, so we have the y-axis, which is here. So basically what we're interested is where the line crosses or intersects with the y-axis. So that's why I call it intercept. Intercepts like two streets running to each other, right? The intercept. So here we're interested in where this line intercepts the y-axis.
0.
Where does that happen? Where does that happen? Megan?
The x around the y.
Well, what's the value of x on the y-axis here? Yeah, x is equal to 0 along this line. Just like over here, right, x is equal to 8, right? You see that the value of x along here is 8. Well, along the y-axis, the value of x is 0. So we just plug in 0 into our equation, and this is our y-axis, sorry, our y-intercept. So basically, you have y is equal to 2 times 0 minus 3 is equal to negative 3. So that's our y-intercept. Okay. So let's go back to first differences. So I've done a little bit different with our notes. I realized the last set was a little bit wordy towards the end. You guys were writing lost on twice. So what I've done is I've put stars beside the key concepts that you need to know after this lesson, instead of summarizing them at the end. So first key concept to write down. Your notes. First differences are the difference between the y values the first differences are the differences between the y values in the table of values that have evenly spaced, that's important, that have evenly spaced evenly spaced x values. Okay, that is nonlinear, should not be there. Okay, and the second key point is the y-intercept. The y-intercept is the value of y in the relation when y is equal to 0. Sorry, when x is equal to 0. Okay, so we did an example with the the y-intercept. Well, let's do an example of the first differences. So the first difference on this first column is nothing. We don't have a first difference there. Okay? For the second row, it's really a y value here. This value minus the value above it. So it's minus 1 minus the value above it, which is negative 3. What is that equal to? So negative 1 minus negative 3. Going back to our arithmetic. I heard answers. 2, right? So that's our first difference there. It's 2.
And then you do it for.
So here we got 1 minus a negative 1.
Just do.
So this is again 2 minus become positive, we get 2. And for this row, it's 3 minus 1. That gives us 2. And here we got 5 minus 3. And that gives us 2.
That's so cool.
So that's our first differences in.
So that's what those are. That is so cool. How can I learn this? Oh, no.
And what it helps while I'm learning it now will be really lots of help from here on in. Well, yeah, what have we noticed? Well, it's the same as the rise, but more specifically, what have we noticed? It's the same as the slope, right? So here, the first difference is, we notice that here they're all 2, and the slope that we calculated over here is 2. Okay? So what we see is that we have a linear relationship. The first difference is what? First of all, is what? What do you know about this column here? What do you know about this column? What do you know about the values? Jenny? No, the values here. They're not increasing by 2. It's all the same. This is a constant. So let's see that if it's a linear relation, our first difference is a constant. And what's the second thing that we noticed, Dean?
Oh no, I got a question.
Okay, what else do we notice? Not only is it a constant, it's also equal to what? It's also equal to, we just said it like 30 seconds ago. Not only was this value a constant in a line, it is also the same as the slope, right? Same as slope as well. Question, Dean?
Yeah. It was like if the slope is a fraction, like 1/8, what would it be?
Your first differences will be 1/8 if it's a linear relation.
So it would come out to be.
Okay, so let's take another example and let's have a practice in first filling in the table of values and calculating the first difference.
This is fun.
No, it's not. Math is never fun.
At least you did it.
Okay, so let me do this in green.
First step.
So what's our y value? Let's quickly calculate the y value. Give you time to write down our tables. So you just need to write down a table. You don't need to do the rulers. It doesn't have to be perfect. Right? Just so you got your table with 3 columns, 5 rows. And then write down the relationship that we have there. Y is equal to negative 2x plus 3. Okay, so when x is 0 in our relationship, what's the value of y in the first one? In other words, what is my y-intercept here? Anthony?
0.
So when x is 0, what's the value of y? We're looking at this relationship.
3.
Sorry? 3. Okay? Well, when x equals 1, Matthew? Sorry, is that 3? Yeah, it is 3. When x equals 1? we plug in x equals 1 to this equation, what do we get for y? So it's negative 2 times 1
-2.
plus 3 gives us, so negative 2 plus 3 gives us, yeah, 1. Okay. So next value, x equals 2. We get 2 times negative 2 is negative 4, plus 3, this gives us a negative 1. Negative 2 times 3 gives us negative 6, plus 3 gives me negative 3. And negative 2 times 4 is negative 8, plus 3 gives me negative 5. Okay, so let's calculate the first differences here. So here I go. I don't have a first difference in that first one, because there's no number above 3 that I could subtract from it. So here was 1 minus 3. Negative 2, right? We did that. So what's negative 1 minus 1? What's that? Negative 1 minus 1? Boy, we need to work. Well, but going back in that first unit, numeracy, well, we did it, right? Thank you, negative 2. Negative 3 minus a negative 1. Those terms are positives. Negative 2. Negative 5 minus a negative 3 on the next one. With a negative 2. So here we got a constant 1. What about our second one in relationship though? Y is equal to 2x squared. So y is equal to 2x squared. What's my y-intercept? Or what is the value of y when x is equal to 0? Is it? 0. It's 0, yeah. 0 squared. 0 times 0 is 0 times 2 still gives me 0. Oh, when x is equal to 1, what's my value of y? 4? 8?
No.
Well, it's 1. 1 squared, so 1 times 1 is? 1 times 2 is 2. Okay. What happens when x is 2? Or 8, sir? 16?
No.
Well, when x is 2, so basically we're doing 2 times 2 squared. 2 times 4, that gives us 8. Right? It's just the 2 being squared, right? Yes.
I just got it.
Okay, that's fine. So when x is 3, so we need to do the squared first. Right? Fed mass tells us we need to do the squared first. Right? So we don't multiply x by 2 and then square it. We need to square it first. So when x is 3, what do we get?
18.
Yeah, 3 squared, which is 9, times 2 is 18. Last one, Paul?
And then 32.
And then 32. Right? 4 squared is 16. 4 times 4 is 16. Times 2 gives me 32. Okay? Just a little bit of a monotonous but slow process. Well, let's go through the first differences. So what's the first difference between when x is 1? What's the first difference?
2.
2 minus 0 is 2.
Next one's 4.
What about this one? What's the first difference there?
8 minus 2 is 6.
So 8 minus 2 equals what, Megan? We'll say 4 if you really meant 6.
I really meant 6.
So the first difference here, 18 minus 8 is 10. And the first difference here, we've got 32 minus 18, 14. So from here, can we tell which relationships is linear?
Yes.
Yes.
Which one?
Constant ones.
The first one?
Yeah.
How come?
First difference is constant.
So this one's linear? Because
You told us.
the first difference is a constant. Okay, that's the reasoning. Just look at those table of values. First difference is a constant. Is the second one linear? So how can we classify that based on what you know? Yeah, so this one we know it's just non-linear.
So it kind of looks like a curve going up if we were to plot it on the graph.
It'll be a curve, and yes, it will look like it's going up. Next year, grade 10, you're going to spend a whole lot of time on equations like the second one, what we call quadratics.
Oh, wonderful.
How do we know that we actually is non-linear, and how you see this in grade 10? On the first equation, what's the exponent on the x?
1.
It's a 1. What's the exponent on the x here?
2.
So basically, you have an exponent that's not 1, you have a non-linear equation.
So the exponent, if it's 0, the equation will not be linear.
Good point. 0 or 1, because then you just have a flat line. You have a slope of 0. Well, actually, no. You still have a coefficient of 1. It just says 0x.
Yeah.
Okay. So here's a couple key concepts you want to get from here. Yes, sir. Because our first differences here are not constant. They have different values here. So the first key concept is if the first differences of a relation, is constant, then the relation is linear. Otherwise, it is nonlinear. Okay, so that's why the second one was nonlinear, because it wasn't, the first difference was not constant. Second thing is the first difference of a linear relation so the first difference of a linear relation, because it's a linear relation, that first difference is going to be constant. So the first difference of a linear relation is also the slope. We've also called this thing constant variation. We've also called this thing constant rate of change. So all those four things, constant first difference, slope, constant variation, constant rate of change, all applies to linear relations. Okay? All sort of like mean the same thing, or tell us the same thing. Any questions? Everybody got this out? So here's another example. State whether the relation is linear or nonlinear. So here I haven't given you the relationship. You don't know what the relation is. You just know the x and y values. Okay? So how can we go off and tell if the relationship is linear or nonlinear? How can we go off and discover or determine if the relationship is linear or nonlinear?
The first difference,
Sarah?
if it's constant or not,
What is constant?
there's values
Which values?
for y.
Yeah.
No. The values of y will always be changing. Yeah, if our first differences is constant. So let's look at this first relation.
Just write this down.
Yes, that's right. You need some time to copy this down. Yes.
Maybe just look at looking at y, and it's like, so it would for, it when the difference between 8 and 10 is 2, the difference between 10 and 13 is 3, so we already know that's not linear. And then you can just do it without doing like the long calculations, right? Well, it's not long.
You just
I
know
know
that-
it's quick.
I just want you to show me that the first differences are not constant then. And how are you gonna demonstrate that to me? I know you can do it in your head, but we get to the point where we need to demonstrate our work, okay? Okay, so quickly draw this table of x and y.
I know.
It's ready to keep you awake. Stop people from falling asleep.
It's true.
Hey, at least I would give you the next x value, 0, 1, 2, 3.
Yeah.
Right? You don't have to look up 4 times to write that down.
Actually, I think it's 4.
The y value is 8, 10, 13, and 17?
That's not the same.
No. So the first differences of this one quickly is 10 minus 8 is here is
2,
2. Second one is 13 minus 10.
3.
So we can already see that. We did finish the table. 17 minus 13 is 4. So is this one linear or non-linear? Non-linear. Because first differences are not constant. Okay, so the second one. So x values again, 0, 1, 2, 3. Y values are 2, 6, 10, 14. So let's go off and do the first difference of this. So nothing for that one, right? So here we got 6 minus 2, 4. 10 minus 6 is 4. And finally the last first difference is?
17.
Yes, 14 minus 10 is 4. So based on this table, is this linear or non-linear?
Linear.
So therefore it's linear. What's the slope?
4.
Okay. Any questions on that? So here's a question. Same table, the right one. All of a sudden we find out the data.
18. Now it's not
Yeah. Also.
linear.
Look, x isn't increasing gradually, you guys. You need to find the value of x.
If you were to plot it,
Well, what's the first difference here?
That's right here.
In this 4, we don't have data for 4. Right? So can we calculate the first difference?
yes, if you already have the first key figured out.
Well, you might be tempted to say, well, this is 22 minus 14, that's 8.
You can do 22 minus 4 to find out the first difference of x equals 4, and then you find
Well,
y.
question, what's the slope between these 2 points here? What's the slope?
No, 8, no, it's 8.
Oh, it's the same line.
No, but it's.
Well, what's the slope? What's the rise here? Or what's the rise? The rise is? How'd you get 8? So I'm gonna do another work
It
here.
went up 8.
Okay, I'm gonna show you some different terminology or different, what's the word I'm looking for? Location.
What is
So the rise is delta y. Oh, this is a triangle.
Triangles are my favorite shape.
It's actually, I think, a Greek symbol to mean.
I don't know why people were doing what Beyonce was singing yesterday. I don't get it.
Oh, it's Illuminati.
Christina, guys, is your test back? Stay on track. We have 15 minutes left. So a triangle means delta, which is Greek for change. Okay? So here the rise is delta y, the change in y between these 2 points. So what's the change in y? 22 minus 14 is 8. Right? The run, I think that is.
What does that say?
Yes.
Is it a square?
Where? Here? Yes.
Oh, that is beside it, right?
This is change. Delta means change, like change in. But delta is Greek, I believe. Greeks were great mathematicians. Well, because you need actually math to be a good architect.
That's why I'm
Surprise, surprise. So what's run? I think we could define run. So rise was delta y, change in y. What do you think run is?
Where?
Delta x.
Wait, what's
Triangle means delta. Let me show change in. So here we change in x. Okay. So what's the change in x here? What's the change in x? So what's the slope here?
It's 4.
So slope is delta y over delta x. 8 over 2 is equal to 4. It's a triangle, so like delta. Delta y over delta x.
Is that an 8?
So it's 8 over 2. So should we assume that, well, if there was a data point 4, then we have the slope between those 2 points, it's still 4.
What?
This is 8 over 2. So we can try to actually assume that while the slope or first differences is still 4, so therefore this is linear. But Paul said something that was really important right before this. So this is great logic. It's great that you're trying to deduce that. But what was the definition of first differences? You don't remember? Go back and look at your notes because you just wrote it down like 5 minutes ago. What do we have to have in first differences?
A constant rate. Or change in between the
First differences.
Evenly spaced.
Evenly spaced. Paul?
Means that the relationship must be linear, which means that x must increase gradually, not unevenly.
So x must increase evenly.
That doesn't count then.
Yeah. So x did not increase evenly here because 4 was missing. So what can we deduce? We don't know.
You do know.
We don't know. The value of 4 could have been 13. The value of the value of y for x equals 4 could have been 17. We don't know. We don't have an equation. So we're just deriving it off our table values. So that's a good point, Steve. We don't have an equation. So we don't really know what the value of y is for x equals 4. So in this case, we don't know if it's linear or nonlinear. And that's how you answer the question. We don't know because we don't know what the first difference is.
So it's really not enough data.
Not enough data, or we just
Not
can't.
enough information.
Not enough
If we had an equation, we could do it.
Yes,
What
sir.
about if there was an equation and it would like skip the 5, would that be okay?
Yeah, because then you can figure out what 4 is. But here we're not given an equation. Okay, so here's a little one example I want to take up quickly. Yes. So we're going to find relationships, speaking about architecture, when you do tiles. When you tile a floor, when you do backsplash, you do little tiles. So this one is 3 centimeters by 3 centimeters.
So we still do.
I'm guessing it's a backsplash or shower.
Those things that are like the tiles.
Yeah, like behind the stove.
Or behind the stove.
Commercials.
Behind the stove, behind the sink.
Okay, so we have tiles that measure 3 by 3 centimeters.
Are we writing this down?
Yes. So I have tiles that measure 3 by 3 centimeters. And we just want to complete the table, this following table for the first 4 rows. So we have x, which is the independent variable, which is our length. Then we want to figure out the area of these rows of tiles. We're going to let that be y, which is our dependent variable, right? Area is going to depend on the length. Then we just have, so before we had delta y, our first differences, now we just have another column for delta x. Change in x, change in y. And there should be actually a 5th column here with number of tiles. So that's along the first one. So 1 tile, 2 tiles, 3 tiles, 4 tiles. Number of tiles. I don't think you could write faster. So here I want number of tiles.
1, 2, 3, 4.
So if I have 1 tile, what's the length? Is it? Yeah, but 1 tile, the length is just 3. We have 2 tiles.
Wait, where's the equation?
We don't know. I'm not giving you one.
Why?
Yes, it is. So I have 2 tiles. What's the length? 6. I've got 3 tiles. Each tile is 3 centimeters,
Oh.
right? 3 centimeters by 3 centimeters. So I have 3 tiles. I put them side by side. Then get the length is 9. I have 4 tiles.
Will it be 12? I need 16.
I just see your weight.
Yeah.
12.
Good.
So Sarah, so if I have 2 tiles together, each was 3, then what's my total length? I just do basic taking these squares and put them side by side.
Anyone have?
So what's the area if there's only 1 tile? What's the area? Any?
3 times the length.
Okay, so 3 times 3 gives me 9.
Okay, we just write 3 times 6.
Yes, you can just write 9 if you can see the pattern. But 3 times 6, so it's 18 is the area there. The length is 9, the width is still 3. So the area is 27, and find 3 times 12 here is 36. Okay, so now we have sort of like a table of values still, except our x increasing constantly? Yeah, it's just not by 1 this time, right? So this is why we want to calculate our delta x now. Delta x before was interesting. What's your delta x here? What's your change in x?
Nothing.
Well, what's the difference here? So this first one is nothing, so here's 9. 27 minus 18 here is 9 as well. So we calculate change in x, or delta x, on that third column, that's what we're getting, right? Sorry, it's not.
Yeah, it's delta y.
Why? Come on, guys.
Well, that's why I said three.
Stay awake. Stay with me.
Wait,
Well, you don't know what happened to you.
I'm keeping yourself over again.
on.
God.
This is delta x. Delta x. The change in x. So it's 3. Change in x here is 3. Change in x here is 3. Boy, I gotta stop testing you guys because you're obviously gonna fail.
Yeah, that's what we're
Miserably.
That's all I do. Don't even.
Just teach you, I know, it's telling you the truth, right? It's not trying to make you think. So what's your delta y? So delta y here. Okay, stay with me now. Sorry, I lost you guys for a bit. Stay with me. So here a change in y is 9, right? This is our first differences. So is the relationship between the length and area linear or nonlinear? Linear. So this is linear because delta y is constant, and so is delta x, right? The difference between our x is also constant, which we need that for first differences.
No.
So basically the same question. You don't have to write down the question, just write down it's linear. So what's the equation? So area, that's your independent variable, right? Sorry, that's your dependent variable. Area is equal to what?
Times the side. I'm at 3
3
times.
pounds.
Plus 8.
3 to the power of 2.
Oh. Okay, settle down. 2 more minutes. So we got 3 because what is our slope?
Well, we should say that area means 3 to the power of 2. And that will still work.
No,
Well, we
not
still
really.
don't have length in there, but it's still
3 to the power 2, it doesn't work for what? Only works for the first one. So what's our slope? How do we get, don't put your stuff away yet, please. Pass it over to when it says. So how do we calculate slope again? Rise over rise. This is the same as delta y.
Yeah, I guess. Okay, class is over. It's fake.
There you go.
It's frozen.
Hey! Do not pack your stuff away, please. We will stay here all through book break if we have to.
Guys,
If you don't think I'm serious, could you not test me on that? Okay, so our slope again is delta y over, or change in y over change in x. So in this case, what is it? What's our delta y? What's your change in y? 9. So that we see our slope is 3. That's how this ties back into our equation.
So the length is the slope? Or no, it's increased.
The change in our rise over rise, so our change in our y values compared to a change in our x values, that's our slope. That was always the definition. So this is our equation. What is the value of the area when the length is 0? I didn't put a table up here. What happens if the length is 0? What's the area? 0. That's our what?
Oh,
Y.
Y.
Y intercept. Okay, so one last key concept. A linear equation or linear relationship has an equation y is equal to mx plus b where m is the slope and b is the y-intercept. Okay, so for the next class, I want you to think about why it makes sense that the value of b is the y-intercept in this equation. Why does that make sense? Okay, for homework, it's on blackboard already.